Chapter 2, Section 3, Equations Involving Decimals. So in this section, what we're going to do is we're going to look at equations that have decimals. So again, you can do one of two things. You can eliminate the decimals by multiplying through by the highest place value, or you can do you can just leave the decimals there and then just use your calculator, which is what I prefer to do. So I'm going to show you with these two problems, I'm going to show you both ways. So again, if I was looking at this equation, I see that I have x terms on opposite sides and I have constant terms on opposite sides. So I need to get like terms on the same side. But I'm going to show you how to get rid of the decimals first. So with this particular problem, what I have is I have a place value term that's to the 10th, a place value term that's to the 100th, and a place value that's to the 10th, and a place value that's to the 100th. So to get rid of the decimals, what you need to do is you need to multiply by the highest place value, which we said was the hundredths. So I'm going to multiply every one of these by 100. So, and again, you can do this in your calculator. 100 times 0.2 is going to be 20x. 100 times 0.24 is going to be just a 24. 100 times 0.8 is going to be 80x. And then 100 times 0.72 is going to be 72. So all the decimals are gone. Now I need to go back to my 2.1 steps and follow those. So I need to get my x terms on one side and my non-x terms on the other side. So I'm going to minus 80x from both sides. And so I'll have negative 60x plus 24 is equal to 72. And then I'm going to minus 24 from both sides. And so I'll have negative 60x is equal to 72 minus 24, which is going to be 48. And then I'm going to divide both sides by negative 60. So those are just following the steps from chapter 2, section 1. And so we're going to get x is equal to. Now, for my answer, it's okay for your answer to be a decimal. So for example, the answer here is going to be negative 0.8. So talk a little bit about algebra etiquette. In the previous section, our equations started with fractions. So when you write your answers need to be in fractional form. However, if your equations start with decimals, then your answer can be in decimal form. So when you take this chapter 2 test, if your equations have fractions in them, then your answers need to be in fractional form. But if your equations start with decimals, then your answers need to be in decimal form. And again, that's just algebra etiquette. Alright, so the problem on the left, I showed you how to get rid of the decimals by multiplying through by the highest place value. Well, on the right hand side, we're just going to work this problem just like we did in 2.1 without getting rid of the decimals. So what I have here is I have like terms on the left hand side. So what I'm going to do is I'm going to combine those like terms. So 0.04 plus 0.08 is going to be 0.12 m is equal to 4.8, so I just combine like terms. And now to get m by itself, I'm going to divide by 0.12. And so m is equal to, and you can put this in your calculator, 4.8 divided by 0.12 is going to be 40. So, take your pick, your choice. You can either get rid of the decimals or not get rid of the decimals. That's completely and totally up to you. Okay, the problem on the left, what I have is 1y. I see 1, there is 1. 1y is equal to 2.16 plus 0.73y. So what I need to do is I need to get these y's on the same side away from this non-y term 2.16. So what I'm going to do is I'm going to minus 0.73y from both sides. So 1 minus 0.73 is equal to 0.27y is equal to 216. And then if I divide both sides by 0.27, I'm going to get y is equal to 8. Alright, for the problem on the right, what we're going to do is we're going to use the distributive property. So we're going to distribute 0.6 times the group of m minus 0.1, and I'm not going to get rid of the decimals. I'm just going to go do the straight up algebra. So 0.6 times m is going to be 0.6 m, and 0.6 times negative 0.1 is going to be negative 0.06. And then the negative 0.5 times m plus 4 is going to be negative 0.5 m, and negative 0.5 times 4 is going to be a negative 2, is equal to 0.34. Now on the left hand side we're going to combine like terms, so I have a 0.6 m minus a 0.5 m, which is going to be a 0.1 m. And then I have a negative 0.06, negative 0.06, and a negative 2, which is going to be negative 2.06, is equal to 0.34. Alright, so now I'm ready to start moving things across the equal sign. I need to move this negative 2.06 across, so I'm going to add 0.26, or 2.06. So I have 0.1 m is equal to 2.4. And then if I divide both sides by 0.1, I'm going to have m is equal to 24. Alright. So now we have applied problems. This is a percent problem. So it says Karen bought a coat at a, I think that should say at a. Karen bought a coat at a 25% discount sale for $97.50. What was the original price of the coat? So for the discount, basically what we have is our original price, which is X, and we don't know what that original price was. X minus the discount, which is 25% times X, so that's going to be 0.25. To change a percent to a decimal, you move the decimal 2 places to the left. So if you have 25%, the decimal is understood to be here. Percent's out of 100, so we're going to move it 2 places to the left. So again, X is your original price minus the discounted price, which is going to be 25% times your original price, has to be equal to $97.50. So if we combine like terms, we have 1x minus 0.25 is going to be 0.75x is equal to 97.50. And then if we divide both sides by 0.75, we're going to get x is equal to 130. So that's going to be your original price. Your original price is $130. Alright, the last problem we're going to do is going to be an applied problem, and this is called a coin problem. It says Aaron has 28 coins consisting only of dimes and quarters, and these coins are worth $4.60. So how many dimes and how many quarters does she have? And I gave you a hint. It says to let X represent the number of dimes, so dimes is going to be X. And the number of quarters can be represented by the total number of coins, which is going to be 28, minus the number of dimes, which is going to be X. This should be the number of dimes. And so what you're going to have to do is you're going to multiply each one of these by its place value and then set it equal to 460. So the place value of dimes is going to be 0.10, so you're going to have 0.10x, and then the value of quarters is going to be 0.25 times 28 minus x, and that has to be equal to $4.60. $4.60. And if you add these two together, you should get $4.60. So if we work this problem, we're going to have the distributive property first. So 0.25 times 28, which is going to be 7. And then 0.25 times negative x is going to be negative 0.25x is equal to 4.60. Alright, so let's combine like terms. So 0.10x minus 0.25x is going to give us a negative 0.15x plus 7 is equal to $4.60, $4.60. Alright, so it's minus 7 from both sides. So I have negative 0.15x is equal to 4.60 minus 7 is going to give us negative 2.4. And then if we divide by negative 0.15, we're going to get x is equal to 16. Alright, so we said that x represented the number of dimes. So there are 16 dimes. And then 28 minus 16 is going to give us the quarters. So 28 minus 16 is going to give us 12 quarters. And again, we can check our work. 16 dimes is going to be $1.60. And 12 quarters is going to be $3. And if we add those two together, that's going to give us $4.60. So it does check out. Alright, so I would like for you to complete these problems on pages 77 and 78. Again, the answers are in the back of the book, and if you need help, either review the video or look in your book for some more examples, as it is a great resource.